Okay, Oak Rovers, this is going to be a video that's going to show you how to use diamond problems and generic rectangles to factor quadratics. But these are going to be special quadratics. And the reason they're special is before I use my diamond problems and generic rectangles, I'm going to be able to factor something out of them first. If I look at my first problem, I have 2x squared plus 22x plus 36. Now before I use my generic rectangle and diamond problems, I can factor something out of all three of those. And if I look at it carefully, all three of these numbers are even. So I can factor a 2 out before I actually use my diamond problems and generic rectangles. If I factor a 2 out, I'm going to have x squared, because 2 times x squared is 2x squared, plus 11x, because 2 times 11x is 22x, plus 18, because 2 times 18 is 36. And now I can use my diamond problems and generic rectangles to actually solve this or complete the factoring of this problem. So I always draw my diamond problem and generic rectangle, and I'm just going to use what's inside the parentheses. The x squared terms goes in the bottom left. The third term or the number goes in the upper right. And I know by Casey's law that when I multiply these two numbers, I get the same product as when I multiply those two. Well, x squared times 18 is going to be 18x squared. So I'm going to put 18x squared up there in the diamond. But I also know, besides these two, the product being 18x squared, I know they have to add up to the middle term, which is 11x. So I'm going to put 11x down here in the bottom. Now I've got to find two numbers that I can add together to make 11x and multiply together to make 18x squared. And I know that 9x and 2x, 9x plus 2x is 11x, and 9x plus times 2x is 18x squared. So these boxes are going to be 9x and 2x. Now remember, it doesn't matter where I put the 9x or where I put the 2x. They just got to go in those two boxes. It won't matter which one I put where. In this row, I can factor an x because they both have an x in common. If this length is x, that length also has to be x. X times x is x squared, and that's why that works. If this length is x and my area is 2x, this side has to be 2. And if this length is x and my area is 9x, that length has to be 9. So to factor this one completely, I have 2 times x plus 9 times x plus 2, because that's what those dimensions are right there. Okay, let's go on to the next one. The next one, I have 18x cubed, and then I have minus 98x. I noticed before I factor this, I can factor something out of this one also. And the cool thing is, if I look at it carefully, I notice that they're both even, so I know I can factor 2 out, but they also both have an x. So I'm going to factor 2x out of both of these. So if I factor 2x out of that, 2x times what is equal to 18x cubed? Well, I know I have to have two x's, so that's x squared, and 2 times 9 is going to be 18. So I have that, and then I have to see what I can factor to make that. 2x times what is equal to 98x. So if I do that, I know that 49 times 2 is 98, so 2 times 40, 2x times 49 is 98x. So now I'm factoring this. Now, there's a shortcut. I could use my diamond problems and generic rectangles for these. And I could put my 9x squared down there and my negative 49 up there. But I'm going to do, there's a little shortcut on these. And I notice what I have here is I'm actually factoring the difference of squares. This number is a perfect square, and that number is a perfect square. And I'm subtracting them, so it's the difference of squares. Now, a squared minus b squared, the difference of squares, when I factor it, is a plus b times a minus b. And we remember that from that problem that we did before. And if you want me to prove that, I can just go here like this and make a generic rectangle and diamond problem for this. And if my lengths are a plus b and a minus b, I get a squared minus b squared AB minus AB. And notice the AB and the minus AB cancel each other out. So what this would equal is a squared minus b squared. So if I look at this carefully, I can tell that when I have a squared minus b squared, it's going to be a plus b times a minus b. Well, what's the square root of 9x squared? Well, the square root of 9 is 3, and the square root of x squared is x. So that's just going to be 3x. And what's the square root of 49? Well, that's 7. So it's going to be 3x plus 7 times 3x minus 7. And that's that special case that we sometimes have. So I don't even have to use a generic rectangle and diamond problem to do that one. So that is how I factor 18x cubed minus 98x. I got 2 more examples to try. The next one, I have 15u to the 4th plus 2u to the 3rd minus u squared. They all have u squareds involved in them. U to the 4th is u times u times u times u. So I have 2 u's in all of them. So I can factor out a u squared before I start this problem. So if I factor out the u squared times what is equal to 15u to the 4th power? It's going to be 15u squared. U squared times what is going to be 2u to the 3rd power? Is this going to be 2u? And u squared times what is u squared? Well, it's just 1. So now I can use my generic rectangle and diamond problem to solve this. I'll put my 15u squared there. I'll put my minus 1 there. Now these two have to add up to the middle term, which is 2u. But when I multiply them, I have to get negative 15u squared. Now to get a negative product, that means my signs have to be opposite of each other. My sum is positive 2, so I know my positive one that's opposite has got to be 2 bigger than the negative one. So I know it's got to be 5u and negative 3u. So I'm going to put each of these into each of these boxes. Doesn't matter where, like I said. In this row, I can factor a 5u out. Well, if this length is 5u and my area is 15u squared, this has to be 3u. If this is 5u and the area is 5u, this has to be 1. If this is 3u and my area is negative 3u, this has to be negative 1. So to factor this completely, it's going to be u squared times 3u plus 1 times 5u minus 1. So that's 3 of them, and I have 1 more to do. The last one, I have u to the 4th power minus u to the 10u squared plus 9. There's nothing I can factor out of them because this one doesn't have any u's, so I can't factor a u out. This is only 1, so there's no numbers I can factor these out. So what I'm going to do is just draw this as a generic rectangle and diamond problem. So when I make my generic rectangle, I put u to the 4th power there and 9 there. And then my diamond problem, I have to have 10u squared, or negative 10u squared has got to be the sum. And 9u to the 4th power has to be my product. Now notice I have a positive product and a negative sum. There's only 2 ways I can get a positive product, either multiplying 2 positive numbers or multiplying 2 negative numbers. In order to get a positive sum with those numbers though, or negative sum, excuse me, because the sign is negative, they both have to be negative. So it's got to be negative 9u squared and minus 1u squared. If I add those together, I get negative 10u squared. If I multiply them together, I get 9u to the 4th power. So I'll put negative 9u squared there and negative 1u squared here. Now, if I factor out here, I can take a u squared out there. If this is u squared, then that also has to be u squared. If this is u squared, that's got to be minus 1. If this is u squared, that's got to be minus 9. So I have this now as u squared minus 1 and u squared minus 9. Now, most of the time you'd think you're done with that, but this one's a little bit different. If you notice, both of these are differences of squares because 9 is a perfect square and so is 1. So to factor this little piece, it's going to be u plus 1 times u minus 1. And to factor this little piece, it's going to be u plus 3 times u minus 3. And that is a video on how to factor differences of squares and quadratics when you have to factor something out before you actually do it.